Greetings and welcome, friends. Mr. Wada here. We're on page 5.6, page 271. We were talking about graphing linear equations, in two variables. All right. Whoa, yikes. There we go. So this is asking us, tell whether the ordered pair is a solution of the inequality. So here's my inequality. It's separated by a little colon there, right? And here is an ordered pair, and they're asking whether or not, if I plug this in for x and this in for y, will that make this inequality true? That's what they're wondering. So let's do a check. So is negative 6 times negative 3 plus 4 times negative 3 less than or equal to 6? So let's see, multiply those. That's going to be 18. 4 times a negative is negative. This is question 7 on the homework from last night's homework. Aha, you're looking at the wrong packet, I think, maybe. All right, is that less than or equal to 6? And 18 minus 12 is exactly 6. Oh, boy. So is this true? Yes, because of the equal part, right? Fortunately, I had that. Right, it's not less. It is, yeah, it hits the equal. So negative 3 is a solution. All right, and we would expect that with this inequality in two variables that there will be lots of solutions, and not just the ones that would be represented by the line when this is equal, but also by those which would be under the line when I shade it. All right, here we go. Did we? Oh, all right, that's weird. Well, that's fine. So here we go. In case you can't tell, this is where this is shaded over here. The black and white didn't really take it. So here we go. Here's a shaded region. And the question is this point a solution of the inequality whose graph is shown? So 1, 4 would be over 1 and up 4. And that point is in the shaded region, so this is a solution. Is a solution. Now, question, what if I asked you about 2, 2? Is 2, 2 a solution? It's right on the line. And why doesn't right on the line count this time? Right, it's only counting that stuff which is above the line, not the stuff on the line, and we signify that with a dashed or dotted line. So this would not be a solution. Neither would be something like 2, -1, which is not in the shaded region, nor on the line. All right, let's get to graphing these. So to do so, this one's, hey, conveniently in slope-intercept form. I'll do a quick slope-intercept form. M is equal to the 3, the number in front. The y is equal to the -1, like so. Let's graph this. We'll use, a lovely blue. All right, let's also actually analyze, what about shading this? Now, this is y compared to something. So y is my vertical axis, so this comparison is going to be an above or below comparison, not a left to right comparison, which would be what it would be if it was an x related to something. And based on this symbol, it says y is less than, and less than in vertical speak would be below. And because it's got the equal part there, it will be a solid line. Salad, like when the Krusty Krab was serving salad and SpongeBob didn't know what it was. -1 is the y-intercept, and the slope is 3, so up 3 and over 1, and up 3 and over 1. Up 3, we're having fun. All right. So, let's draw this line. I've got my little straight edge tool here. A ruler. It's a solid line, so I'll draw a solid line. And we are expecting to shade this, I believe you guys told me, below. Or actually, I said it, right? Because less than. So all of the points less than this line would be the points like this in here, right? All of these points. Lovely. Look at that lovely blue. So you guys got your colored pencils, and I've got my little shading tool here. I love it. So, let's look at another one. So this one was convenient that it was already in slope-intercept form, and so there are infinitely many solutions. In this case, it includes the ones on the line as well as the ones in the shaded half plane, we called those. All right, we've got to switch this into slope-intercept form. Now, technically, you could do a table of values. Technically, you could graph using the intercepts method. When you use either of those, you would have to then pick a point on one half and check it to figure out your shaded region like the book said yesterday. But if it's in slope-intercept form, we can just use logic to discern which way to shade. So I've got the opposite of y is greater than or equal to that. That is not quite slope-intercept form, so I'm going to either multiply or divide both sides by -1. And I just said the magic word. I said multiply and -1, or I said divide and -1 in a world of inequalities. I'm sad that we live in a world of inequalities, friends. I'm sorry. But nonetheless, math is still true. Thank goodness for math. So I flip that inequality when I divide or multiply by a negative. And -3 divided by -1 is +3x, and 5 divided by -1 is minus not 1, but 5. All right, so the slope is the 3, the y-intercept is the -5. Let's go for a purple this time. Ooh, school colors. So let's see, plot this point right there. The slope is 3. Hey, same slope as last time, up 3 over 1, up 3 over 1, up 3 over 1. Now, wait a minute, don't you draw that line, friends. I've got to analyze. Analyzing inequality symbol. All right. It is y is, bless you, less than something. So y is the vertical axis, so I'm thinking about above or below, not left to right. And less than would be below. And this has got the equal part, so it's solid. Ah, man, I unfortunately chose two things of nearly identical examples. And actually, my line tool is still going to have exactly the same slope from earlier, so watch this. I can just shift it down, and it'll still match up. Oh, what? Because those lines are parallel. Solid line. And let's shade below. All right. Ooh, look at that purple. I love it. All right. Loving the purple. All right. All right. Ooh, wow. Lovely, lovely. So there we go. I think that's all the problems I picked. So thanks for watching, internet friends. Have a great day.